Okay, so we're going to review. I made a mistake on yesterday's lesson, and I'm going to correct it once we get there, okay? So, the first part we looked at was complex numbers. You have several things you're going to do with them. You have adding, subtracting, multiplying by a scalar, multiplying binomials, and then dividing complex numbers. So just want to go over a few examples. Remember that I squared has a value of -1, right? And that the square root of -1 is where we get our I from. It's imaginary, it's not real. Make sure that your answers are written in this form where the real is first and the imaginary is second. Okay? Adding and subtracting, just make sure you add and subtract like things. So you're going to add your real terms together and you're going to add your imaginary terms together. Okay? Be careful of minuses. Make sure that you are picking that minus up every time. Okay? Multiplying complex numbers. We multiplied monomials. We had a few of those. Just multiply the number parts and then multiply the i's. And remember, when you get I squared, it goes away and it changes the sign in front of the term. Okay, now if you ended up with just I squared, this goes away and it's really -1 there, okay? If you have binomials or you have a squared, make sure you write that one twice and you're going to FOIL it, okay? So we're going to multiply by foiling, and you'll notice that in the middle you've got like terms, that is your I term, and then at the end you have an I squared term. So remember, that cancels out and it changes the sign of the term in front. So this 15 becomes a negative now. So we have 24 minus 15, which is 9, and then -18i minus 20i is -38i. Make sure real numbers first, imaginary numbers second. Then we did some dividing. The first type of dividing we did had a single term in the denominator. So when you have just one term in the denominator, you're just going to multiply by that term so that it gets rid of the I. The goal here is to remove the I from the denominator. Up top, you're going to distribute. In the bottom, you're going to multiply. Any I squares you have, remember, change the sign in front of it. So writing your real number first, then your imaginary. If you can reduce the whole fraction by something, then divide it. So I can reduce everything by -2. It's got a negative down here, so I want to get rid of the negative in the denominator as well. Most of the time, that's the way it's going to be written. So I'm going to divide every term by -2. That gives me a 3, -5i, and then a +2 on the bottom. So that would be your simplified radical solution. Now, when I ask for the answer, I expect that it is in simple fraction form, okay? So no i's in the denominator. All right, and then we went into matrices, okay? Now remember, matrices, they are given subscripts when they're talked about. And these little subscripts, the first number is your row, the second number is your column, okay? So if I wanted row 1, column 3, that would be a 3. That's what's in that position. If I wanted row 3, column 1, row 3, column 1, that would be a 7. If it does not exist, then it is called undefined. Okay, so if for some reason they asked you for a sub 1, 4. Well, we don't have a fourth term here in the columns, so this would be undefined. Okay. Matrices have order or dimension. It's how many rows to columns it is. So you always label them this way: rows first, columns second. This is a 3 by 3. Now, in order to add and subtract, they must be the same dimension or the same order. So this is a 2 by 2. It can be added to a 2 by 2. It cannot be added to a 2 by 3. So to add and subtract, they have to be the same size. All right. You are going to add and subtract the common entries. So first row, first column, first row, first column gives me an entry in my first row, first column. Okay. And you go all the way through like that. Wherever that position is of the numbers that you added together, that's the position of your solution. Okay? Adding and subtracting, they must be the same size. Then we did a couple of multiplying by a scalar. This is just like the distributive property. So you would take the 4 and distribute it to each term, multiplying each of them by that 4. Your matrix will be the same size that you start with if you're only multiplying by a scalar. Okay? You had some solving. If you had a matrix that was missing, just move over what you know mathematically. So this is being added, so I would move it by subtracting it. And then I just put that same matrix right here, only I'm subtracting it because I moved it to the other side of the equal sign. Okay? So once you do this operation, that gives you the J matrix. Okay? You could have multiplication in front of that. It could be several different things. Okay? If it's multiplication, opposite operation to get rid of the 5 means I'm going to divide by the 5. So I do that on both sides. So just divide each term by -5 and you get your solution matrix. Okay? Going to be the same side if you're just adding, subtracting, or multiplying by a scalar. If you're missing the whole matrix, again, move the matrix that you have by subtracting it to the other side. Do the math here. Get that new matrix after you subtract, and then divide by 2. So take that answer and divide it by 2, and that will be your new matrix. So if we do 3 minus a -3, that's 6. 8 minus 0 is 8. 11 minus -3 is 14. And -3 minus 1 is a -4. Then we would divide by 2 all the way through the matrix, and this would be our solution. Okay? If you have some solving, you're going to set the problem up just like it needs to be set up. First row, first column equal to first row, first column. You notice the variables are the same. They should be in order for you to solve them. Get your x's together and then find the solution. Your answer will go in the same position your problem was. It was in the first row, first position. Okay? So you would just solve for each of these. Set each of them equal to each other, the proper value, and then find your solution. So this is my x, this is my a, because that's what was there. Okay? You may have some like this where I just spell out what you're supposed to do. So I'm telling you to multiply a by 2. You could do that right off the bat very easily. Most of these are real simple math. And then you want to subtract from that the b. Make sure you're paying attention to the matrix they're asking you about, because sometimes they switch those a's and b's up. So make sure you're putting the right one there. And then once you've distributed anything, then go ahead and do the add or subtract. This one's a little bit more complicated because it's got more parts. But I would do this minus A, so change the sign on A. We're going to keep this 1/2 x because that's what we don't know. But we're going to go ahead and do half of B. So we're just going to divide everything in B by half. Okay? The simple math is to subtract that matrix that's being added. Okay, so we're just subtracting it. Still have my 1/2 x that I don't know. And then I'm just going to do the math here. So -4 minus a -11, +7. 4 minus 8, -4. 5 minus a -1, 6. And -4 minus 4, -8. If I'm multiplying by a half, I can multiply by 2 to get rid of it. So my new matrix, after I've taken the negative of A, half to B, subtracted those, and multiplied it by 2, I get 14, -8, 12, and -16 as my final matrix. Okay? Now I want to very quickly go over something that I made a mistake on yesterday, and that was this right here, this statement. Hopefully I'm going to have enough time to do what I need to do. The columns of the first matrix has to be the same as the rows in the second matrix. I said it backwards yesterday, wrote it backwards yesterday, and I apologize for that. But if we have a 1/3 and a 3/1, this tells you that we can multiply. These have to be the same. And then these outsides tell you your solution matrix. How big is it? So our solution for this one yesterday when we did it was a 1/1. Okay? But the middle has to be the same dimension. Okay? So just want to go over a couple of these. This is a 2/3 and a 3/2. The middle is the same, and that means we can multiply, and the 2/2 would be my solution. Okay? And we're gonna do what we did. The process was correct. It's just I said this backwards. So the column of the first and the rows of the second have to be the same. So these inside numbers here. And then the outside terms, rows of the first, columns of the second, will tell you what your matrix looks like. Okay? So let's see if I got another one here. This one is a 2/4, and this was a 4/2. Because these are the same, we can multiply, and 2/2 would be my solution. This is a 3/3 and a 3/3. These are the same, so I can multiply, and that's what my solution will be. Just want to go over how to multiply them to make sure. Row 1 to column 1, we're going to do entry for entry, that first term to first term, plus second term to second term, plus third term to third term. Okay? We're going to do that for row 1, column 2 as well. So 2 is my first term is -4. Second term is a 1, and my second one in the column is a 2. Third is a 3, and my column has a 0. Alright, we're also going to do it for the second row. We'll start with the first column, and we're going to go second row, first column, first entry, second entry, third entry. We're going to do the same thing for the second row or second column. First entry, second entry, third entry. Okay? Your new matrix is going to be a 2/2. Your zeros are going to go away. Not sure if I'm going to get all this in there, but we'll try. So you got 2 minus 3. You got -8 plus 2. You got 2 and 2. Okay? So remember, insides have to be the same. Outside tells you what it is.